Ladies and gentlemen, now we will start our second lecture of the analyze phase. During the lecture, the following topics will be covered: cause and effect diagrams, cause and effect matrix. We will start with the foundation stone of the analyze phase. You should do the analysis in 360-degree. To do the 360-degree analysis, we will start with data analysis. We will use different tools in data analysis, like voice of the customer, VOC, Kano model, data collection, check sheets, transforming data, etc. Then, we will do the process analysis. We will use the following tools for process analysis: spaghetti diagrams, process map, SIPIC, value stream mapping, visual process controls, failure mode and effects analysis, FMEA. The last part for 360-degree analysis is the people analysis using brainstorming, which leads us back to the data analysis. Why should we use the cause and effect diagrams? To ensure that a balanced list of ideas have been generated during brainstorming, or that major possible causes are not overlooked. To explore all the potential or real causes, either it is root causes or inputs that result in a single effect or output. To identify areas where there may be problems and compare the relative importance of different causes. Please note that causes are arranged according to their level of importance or detail, resulting in a depiction of relationships and hierarchy of events. The cause and effect diagram is the brainchild of Kaoru Ishikawa, who pioneered quality management processes in the Kawasaki shipyards. Causes, in cause and effect diagram, are frequently arranged into 4 major categories. While these categories can be anything, you will often see in manufacturing: manpower, methods, materials, and machinery; in services and administration, equipment, policies, procedures, and people. Other categories may be nature, measurements. Work through each category, brainstorming potential causes, and asking why each major cause happens. How to create a cause and effect diagram. Step 1. Identify and define the effect. Step 2. Fill in the effect box and draw the spine. Step 3. Identify main categories. Step 4. Identify causes influencing the effect. Step 5. Add detailed levels. Step 6. Analyze the diagram. Now, we will practice the steps to create cause and effect diagram through an example. 1. Identify and define the effect for car poor gas mileage. 2. Fill in the effect box and draw the spine. 3. Identify main categories: machinery, materials, people, and methods. 4. Identify causes influencing the effect. For example, for methods, drive too fast and use wrong gears. For people, poor maintenance and poor driving habits. 5. Add detailed levels and analyze the diagram. For example, for use wrong gear, we can add cannot hear engine because either poor hearing or radio too loud. For poor maintenance, because either money wise or no awareness. In order to create cause and effect diagram using Sigma XL, either click Sigma XL, then analyze templates and calculators, then click cause and effect, fishbone, diagram to access the cause and effect diagram form. Or, click Sigma XL, then Analyze Templates and Calculators, then click Cause and Effect Fishbone Template to access the cause and effect diagram template. In order to create cause and effect diagram using iGraphX, click New, then Cause and Effect, then choose the suitable template, either manufacturing or transactional. Now, we will make an exercise for the cause and effect of the following problem. The production efficiency is not good. Please follow the steps in order to complete the cause and effect diagram. Please pause the lecture and solve the exercise. The main categories for the low production efficiency are manpower, methods, IT issues, machinery, and material suppliers. Please check the causes influencing the main categories and compare them with your solution. Another example for the cause and effect diagram. The effect is computer downtime. The main categories are software, users, hardware, and environment. Detailed levels for software are faulty design, faulty installation, faulty media, and inadequate documentation. Detailed levels for hardware are power fluctuations, faulty components, component failure, and inadequate power. Detailed levels for users are lack of training, abuse of hardware, misapplication of software, and misuse of hardware. Detailed levels for environment are corrosion, mechanical shock, humidity, and temperature gradient. For the first activity, on cause and effect, complete the causes and effects diagram to show the major categories in order to identify the sources of variation in the production process in any manufacturing system. Please perform the activity and send your output by email for assessment. For the second activity, on cause and effect, please download the Research Root Cause Assessment for a Manufacturing Industry, a case study, and read it carefully. Create the cause and effect diagram according to the information in the paper. Please perform the activity and send it by email for assessment. For the third activity, on cause and effect, please download the Research the application of cause and effect diagram in the oil industry in Iran, the case of 4-liter oil canning process of Sepahan Oil Company, and read it carefully. Make a short presentation to illustrate how the researcher used the CTQ, Pareto chart, and cause and effect diagram to relate potential causes of a major presenting problem. Please perform the activity and send it by email for assessment. Process mapping can be viewed as a method that results in a possible list of subsystem inputs for further study. In that view, cause and effect matrix, cause and effect methods could prioritize this list for further exploration, taking into account information from customers and current engineering insights. To apply the cause and effect method, it is helpful to recall basic matrix operations of transpose and multiplication. To perform a cause and effect matrix, we should know the transpose of matrix. The transpose of matrix contains the same numbers moved into different positions. For every number in the transposition, the former column address is now the row, and the former row address is now the column address. For example, the following is an example of A and transpose of A. When two matrices are multiplied, each entry in the result is a row in the first matrix, product into a column in the second matrix. In this product operation, each element in the first row is multiplied by a corresponding element in the second column, and the results are added together. For example, matrix A consists of 5 and 4, 2 and 3, minus 3 and 4, while matrix B consists of 2 and 12, 6 and 9. A multiply B, the element in first column in raw, will be 5 times 2 plus 4 times 6, which is equal to 34. The other elements will be calculated in the same way as shown. Back to cause and effect matrix. To construct the matrix, please follow the following steps. Step 1. Identify and document Q of C, customer issues in a language customers can understand. If available, the same issues from a benchmarking chart can be used. Step 2. Collect ratings from the customers, R of J, for J equal from 1 until QC, of the subjective importance of each of the Q customers' issues. Write either the average number or the consensus of a group of customers. Step 3. Identify and document the system inputs from X1 until XM and outputs from Y1 until YQ, believed to be most relevant. If available, the same inputs and outputs from a benchmarking chart can be used. Step 4. Collect and document 1 to 10, 10 is highest, ratings from engineers of the correlations, C, of I and J, for I from 1 until QC, and J from 1 until M plus Q, and between the QC customer criteria, and inputs, and outputs. Step 5. Calculate the vector transpose of F, which is equal to transpose of R, times C, and use the values to prioritize the importance of system inputs and outputs for additional investigation. In order to understand the calculations better, we have to study the following example carefully. A Midwest software company is trying to prioritize possible design changes, which will be used as inputs for their software product design problem. They are able to develop consensus ratings from 2 customers and 2 product engineers. Construct a cause and effect matrix to help them prioritize with regard to 9 possible features. In discussions with software users, 7 issues were identified, QC equal to 7. Consensus ratings for the importance of each were developed. Through discussions with software engineer, the guesses were made about the correlations were guessed between the customer issues and the M equal to 9 inputs. No outputs were considered, so Q equal to 0. Table shows the results. The 7 customer issues were easy to use, helpful user environment, good examples, powerful enough method covered, good help and support, and low price. Each issue has a customer rating. They have been listed in order as the issues. The customer ratings are forming the vector R. We have 9 possible features, so we have 9 inputs. Include logistic regression, import text to limited data, include the OE, include optimization, include random factors, improve stability, improve examples, regression formula outputs, and wizard for first time. The correlations between the 7 customer issues and outputs are listed. The correlation factors are forming the matrix C. To calculate the vector transpose of F, we will do the multiplication of transpose of R multiplied by C. To do this multiplication, we will use Excel function matrix multiply, a vector transpose of R, n, each column of matrix C. For example, For first element of transpose of F, it is equal to M mult of A12, G1N, I12, I7. The second element of transpose of F, it is equal to M mult of A1 to G1N, J12, J7, and so on. Here is the result of transpose of F. The results suggest that regression formula outputs and a wizard for first-timers should receive top priority if the desires of customers are to be respected. Instead of doing this complicated calculations to perform the cause and effect matrix, you can use either cause and effect templates, or use Sigma XL, or use Minitab. To access cause and effect matrix templates in Sigma XL, click Sigma XL, then Analyze Templates and Calculators, then Cause and Effect XY Matrix. This is a simple cause and effect matrix template. If prompted, please ensure that macros are enabled in order to allow Pareto charts to be created. Click the Pareto chart button to create a Pareto chart of weighted scores by input and process variables. To access cause and effect matrix templates in Minitab, click New in Minitab workspace, then click Cause and Effect XY Matrix button. This is cause and effect matrix. You can add and enter the inputs X's and the outputs Y's. Also, enter weighted value by input for each output. In addition, you should enter importance of each output to the customer outputs. The Pareto chart of weighted scores by input and process variables will be created automatic. Please download from the resources the instructional video for cause and effect diagram and matrix using Sigma XL, Minitab and iGraphX. Cause and effect diagram and matrix Sigma XL.mp4. Cause and effect matrix Minitab.mp4. Cause and effect diagrams iGraphX.mp4. Please perform the activity and send your outputs by email for assessment. Thank you, and see you in the third lecture of the Analyze phase.